Hello and welcome to another video of Meneer Schoolmeesters. In this video I'm going to talk to you about compound interest. I'm going to explain what it is and how you can calculate it. This is dealt with in the book Buying and Working from LWEO, the Dutch abbreviation, and it's for economics on 3 HAVO VWO. So compound interest. Compound interest means interest on interest. So you got a savings account, you receive interest, and instead of withdrawing the interest and buying something nice with it, you say, I leave it in my account, and the next year I don't only get interest on the amount that I put in, but also on the interest that I earned last year. So interest on the interest I already gained. This means that the growth of your bank account will be exponential, and this can only be used in a savings account. All right, so we've got an example, and the example is that I've got a savings account and I deposited 1,000 euros in the savings account, and I agreed with the bank that I get an astonishing rate of 5% interest per year, compound interest that is. So what do? The first year we start with 1,000 euros. 50 euros worth of interest is added at the end because 5% of 1,000 euros is 50 euros. And so at the end of this year, and the first year, I've got an amount of 1,050 euros. So what I end with in this year, I start with the next year, obviously. So in the beginning of year 2, I start with an amount of 1,050 and 5% is 52.50 in interest. So at the end of this year, I have an amount of 1,102 euros and 50 cents. I leave that in my account as well. So in the third year, I start with 1,102 euros 50, and the interest 5% is 55.13. So at the end, I've got an amount of 1,157.63. So as we can see that in the first year, I got 50 euros interest, and in the second year, it already grew by 2.5 euros. And in the third year, the growth was even bigger because in the third year, the interest grew by 2.63. So we see that the interest grows bigger and bigger, which means that this growth is exponential. Were it linear, then the growth would be 50 euros every time. So the growth would be exactly the same. But now, because the growth becomes bigger and bigger, we call it exponential growth. So I've added 2 words here, growth factor, and the growth factor is 1.05 because every year, if I multiply the beginning by 1.05, the end is calculated. So each year, this bank account grows by 1.5 factor, so multiply by 1.05. Well, I can easily say if the growth factor is 1.05, I can write this down shorter, and I can say 1,000 euros with which we start times 1.05 times 1.05 times 1.05 gives me the exact same amount as at the end of the third year. Well, as you can see, I multiply it by the growth factor, which I explained here as well. Now, if you're very smart, and most of my subscribers are very smart, you can also say, I can write this down shorter, and I can say 1,000 euros times 1.05 to the power 3 is 1,157.63. Now, most of the time in tests, teachers want you to calculate the end value of a certain savings account. And if the period is 3 years, then you can easily calculate it like this. But teachers are how teachers are, and they will ask you to calculate the value at the end after 50 or 60 years. Then you can also do it like this, but the amount of time that it will take is too long for you to answer any other questions, so you'll be left with an insufficient mark. So I'm going to explain to you how you can do it like this, and I'm going to explain to you the definition in the book. Namely, the formula, as we established, 1,000 euros times 1.05 to the power 3 equals 1,157.63. So what do we have? The formula in the book says initial value times 1 plus I to the power n equals the n value after n periods. Now, how can I translate this to this example? The initial value is the amount that you begin with, 1,000 euros. Then 1 plus I being the interest rate, 5%. 5% literally means per 100, so 500. And if you're not sure how to calculate it, you just say 5 divided by 100, because the interest rate is 5%, so 5 divided by 100 times plus 1. Yes, so 5 divided by 100 plus 1 is 1 plus I. Then to the power n. N is the number of periods, in this case years, because the interest rate is per year. But the period can also be, for example, a quarter, a month, or half a year. So you have to be very careful and read the assignment very careful, what the interest rate is about, what period the interest rate is about. In this case, it was years, so n is the number of years. And then the n value is obviously the value at the end of the amount of periods that is asked. So in this case, after n periods, 3 years in this case. All right. Let's give you some examples. In order to get the periods right and the interest rate right, I've come up with 3 examples, and in a minute I'll ask you to pause the video, and I want you to try to calculate the n value of these 3 examples. So the first one being 5,000 with 0.5% interest per month for 6 years, and the second one 6,000. Well, you can read interest. So what I want you to do is I want you to calculate the examples, so the n values for each example. So I'll give you the opportunity to pause now, and hopefully you got them right now, so you can unpause, and I will deal with you with the calculations. So the first one, 5,000 euros times 1.005. So this goes wrong quite a lot actually, because 0.5% means 0.5 divided by 100, which is 0.005. Add the 1, so 1.005. Yes, punch it in your calculator, 0.5 divided by 100 plus 1. Interest is 6 years, but the interest is per month, so the period is month. There are 72 months within 6 years, so times to the power 72, which gives us 7,160. Some people say, well, 0.5% interest is the same as 6% per year, but you can't do that because you get interest on the interest you got the first month as well. So you can't do that. You could, for fun, try to calculate it with 6% per year and then with 6 years, and then you will find out that the amount is smaller than this. So you can't say, I'll translate it from month to year. So you have to keep with the month that is given. The second one, 6,000 euros, 1% per quarter. 1 quarter, 4 quarters per year, so 4 years, 16 quarters, gives us 7,035.47 euros. And the last one, 2% per half year, 5.5 years is 11 half years. So hopefully you got it right. And my tip to you is, if you don't know how to do this, just punch in your calculator 0.5 divided by 100, 1 divided by 100, 2 divided by 100, and all plus 1. Yes, and try to get the periods right. So hopefully you got it now. Try to find some more examples on the internet with which you can practice, because this is just a trick, and practice in this case does make perfect. So I would like to see you back again Don't forget to subscribe here on this button, and I'll see you next time. Cheers.